Hey guys, it's Mrs. Beckler. I'm working number 17, 18, 31, and 32 from page 404 for you guys. Lily let me know that you guys needed some help, and that's what I'm here for. You need to reach out and ask me if you have questions and stuff you can't figure out. Once I do one of these, you really are not going to need me to do more than one of them. So let's start with number 17 right here. Okay. We have a perpendicular radius to a chord. Well, what does that perpendicular radius tell us? It tells us that the chord is split in half. So RS, or R to the center, I should say, and the center to S, those are congruent. Okay, so we know that because that's one of the chord theorems. Okay, the segment from P to the chord is 5, and from the chord to Q is 8. So that whole segment is 13. Well, that whole segment is a radius. So I'm going to strategically draw a radius from P to S. Aha, I now have a right triangle. So this is 13, PS is. This is 5, and I now have a right triangle. So this is 5, this is 13, this is a right angle, and now I need to know what from the center here to S is. Well, that's this segment. So see, I've just taken that triangle and drawn it over here. Well, I don't know if you recognize it, but it's 5 squared plus b squared equals 13 squared. Just use the Pythagorean theorem. And I don't know if you recognize this. This is one of the triples that Miss Spear was talking about. So 25 plus b squared is 169, so b squared is 144, so guess what b is? B is 12. So that's 12. So that segment is 12, which means from the center to S is also 12, which means R to S, remember it was bisected, so R to S has to be 24. And that's how you do it. That's how actually you do all of these. Okay, so let's look at 18. Okay, you have from C to here is 50, from here to D is 20, so that means CD, the radius, is 70. So draw your radius here, and that's 70. Use the Pythagorean theorem to find this segment from this point here down, and that's going to give us this time I'll treat it as A squared plus 50 squared equals 70 squared. Pythagorean theorem again. So let's see, 70 squared is 4,900, 5 squared is 2,500, plus a squared, and let's see, that's going to give us 2,400, and that one's not a perfect square, is it? No. So let's just break it down. If we divide it by 2, that's 2 times 1,200, actually, let's do it like this. Let's do 60 times 40 and do that as 6 times 2 times 5. And that's 4 times 2 times 5. And that's 2 times 3 times 2 times 5 times 2 times 2 times 2 times 5. So let's start taking pairs out. See, a pair of 2's, another pair of 2's, and then a pair of 5's. So that's 5 times 2 is 10 times 2 is 20. So 20 root 6. There we go. Okay, 20 root 6. That is the length from here down, right? Oops, here's the picture. From here down. So that's 20 root 6. But we know that this segment was cut in half because we have a right angle here, and that theorem tells us if a radius cuts a chord in half, then there's a right angle, or if we have the right angle, then the chord's cut in half. So let's double that. So that's 40 root 6. And there's our answer. There you go. Okay, now what I want you to do is see if you can work 31 and 32, which is the same premise there. But notice on 32, from here to the chord is 3, and then it's marked congruent from here to Q. So remember, those are both 3. So think about, well, what's your radius going to be? So what's PS going to be? Hopefully you're saying 6. And then you can work it from there. Okay, so work through those last few, and you can check your answers on the key I posted for you. Hope this video is helpful, and let me know if you need something else.